Technology is one of the factors that rapidly shapes our environment. With India's growing importance as a manufacturing hub, it is vital that companies also have access to the best technologies, allowing us to keep pace with global standards and create our own niche. This is how the Center for Industry 4.0 came about, an initiative by the Ministry of Heavy Industries of the Government of India as part of the Smart Automated Manufacturing and Rapid Transformation Hub. The C4I4 Lab brings together the government, industry, academia, and industry associations. At its core, it is a collaborative venture that is pushing the manufacturing industry in India to new heights by creating tangible, impactful change. To achieve this, the C4I4 Labs is partnering with industries and has developed our very own Industry 4.0 Maturity and Readiness Assessment tool, known as the Industry 4.0 Manufacturing Model. We also have a capability building initiative with Digital Champions Program for management professionals and hands-on training to allow industry professionals to interact with Industry 4.0 technologies. We also have an iFactory network with over 10 centers across the nation. So, now that we have an understanding of why Industry 4.0 is critical and how the C4I4 labs are helping push this revolution in India, through this series of seminars, we will be witnessing further light shed on the topic of industrial IoT and how Indian manufacturers are adopting it to suit their own unique requirements. On this note, I would like to welcome our first speaker of the day, Mr. Dheeraj Podutwar, Business Development Manager at our tech partner, Pilz India Pvt Ltd, to deliver the session on challenges on the way towards Industry 4.0. Sir?
Thank you very much for the introduction. So, as today's topic you are very well aware about, we'll be talking about the Industry 4.0. So, before starting with the topic, let me just introduce myself. I'm Dheeraj Podutwar and I'm from Pilz India Pvt Ltd. So, in today's topic, we are talking about safety and security related aspects of the Industry 4.0. Each company has their own product, their own networking philosophies, and some standards which needs to be followed whenever we are implementing any network solution. At the same time, this network solution when we are implementing has to be safe and secure so that unwanted authorizations, misuse, malicious activities shall be prohibited. There can be possibility of hacking into the machinery or network. There can be possibility of ransomware. And so aspect of security and safety plays very important role in case whenever we are implementing the Industry 4.0 solutions. So just as this is the fourth revolution. So what are the previous three? First revolution, when industrial production start with the steam energy, water energy. Locomotive engine is a quite good example. Second generation, typically it's an era of a mass production when electrical equipment starts manufacturing, but it was extensive labor used. Even though there were electricity present, but still extensive labor was used. And then in third industrial era, what we see a revolution with respect to the machinery in terms of a usage of a controlled product, safety PLCs. Previous generation, we used to have a contactor logics wherein lot of hard wiring is required. But now in the third generation, what we need is a controller based. So we have a lot of possibilities or control mechanism. Now we are entering into the fourth generation where all the devices, manufacturing units will be connected centrally. May not be a hardware, but maybe through some IoT, cloud solutions, IIoT. So in this case, what will be the challenges? That we are going to discuss in today's topic. So how the production will look like in 2025 and beyond. Typically, it will be high level of product individualization beyond standard configuration. Now what we have, one system, their control system, mechanical aspect, which is interlinked with other machinery or equipment via some hard protocols. But after 2025, or what is going on with the revolution of Industry 4.0, each unit will have its own mind. It will be controlled centralized way. If any failure happen or any changes needed, that has to be certified on an individual level, not on a all machinery level. Okay, so in this case, decentralization will play very important role, and each unit will have their own flexibility. Simple cutting, after cutting operation on the machine, if you want to do the laser welding, it may not be a part of that equipment itself. If there is a failure or changes you need into the one machines, only you need to configure decentralization's part in a laser marking equipment, for example. And that only unit needs to be a certified rather than going with the complete system certifications. Of course, integration plays very important role. So we are integrating not just machinery but our network and office systems also. For example, say production related system, ERP system, SAP. If that also wants to be integrated, and if you want to manufacture a part on a lot basis or single part also can be generated, then that has to be done in decentralized way. So in this case, there are a lot of tools and lot of products will be required to be interlinked, and that has to be adopted and controlled in a coordinated manner, considering safety and security aspects as well. Just imagine you have a plant machinery operating, taking some parts of a production, 1,000 numbers of parts are being generated, and suddenly due to some attack, cyber attack or cyber security related threat, you are not able to run your machine. Example, ransomware attacks. Nowadays it is very much common. You may have heard many times in the news. If ransomware attack happens, what happens? You are not able to run your equipments unless and until you are going to pay some amount. It means virtually your production is at standstill. And hence, considering all those threat aspects, when we are integrating all those aspects into the machinery like cloud technology, IIoT, industrial networking along with the security plays very important role. So in this case, the product which we are going to use, they itself can generate lot of information. In example, if some person want to access the machine, first thing you need to check is whether he is really an authorized person or not. In simple, many of the machinery you see, auto mode, manual mode, setting mode, different type of operating modes are there. But do you know who are the people operating these modes? Really they are authorized to do this activity or not? Or any person can have access to these operating modes of the machinery. So in this case, authorization plays very important role, and here instead of conventional mode selection, you have to go with some standard or safety product wherein security is also guaranteed. It means that person who has access to the machine, their data is also captured by that product itself. Maybe it is related to the person name or their authorization, but apart from this, security level, permission level, maybe some unique code like hex code or RFID code, that will make sure that person is correct and he is authorized to carry out certain actions on the machine. So the products which we are going to use, that product itself will generate lot of information, and those products will be connected in centralized way. It can be connected in decentralized or centralized, both way. So overall meaning is they will be network product. And hence in this case, whenever network products are there, certain protocol or certain compliance with respect to the standard needs to be followed, so that there will not be a possibility of cyber security related threats. So in this case, machinery will be a part of system, your IT equipment will be a part of system, then automation devices, people, they are also part of our existing system. And hence, when we want to achieve overall safety, then safety as well as security plays very important role. So typically it's a, when industry 4.0 concept we are saying, it's a modular plants. Each individual units have its own role. They will have their own control functionality, which will be controlled separately via some equipment or products. So we have to manage both safety as well as security aspects of the machinery. So what is meant by safety in this case? Yes, we are preventing untoward incidents or accident into the machinery via some products usage, maybe some access control devices, safety gates devices, scanning devices. And what is meant by security? We are preventing unauthorized access or loss of expertise or loss of data when we are integrating all those aspects into the machinery. Quick example, here one robot cell is shown here over here. So what is meant by safety in this case? Protection of man and environment from hazard related to the machinery. So what is hazard here? Robot itself can generate lot of hazards. Trapping hazard, crushing hazard, impact hazard. Just imagine if you get a trap between a fixed part and robot. Worst case, there may be a possibility of loss of expertise also. And hence here safety will plays integral role. Along with this, what is meant by security then? Whether the person who has access to this machinery is authorized person or not. The person who has entered the cell to carry out this certain modification, maybe loading, unloading activity, or to do some minor maintenance activities, which is integral part of a production process. So in this case, that person authentication, authorization, that also needs to be verified, and that we have to do some via security mechanisms. So there are some standards by which we can do this. We will come into later session of the presentations. So here now, what happened in the industry 3.0, for example, there is a clear separation between the process and a person. So you are having a robot. How we are maintaining a safe distance between the person? By enclosing the complete process. For entering the robot cell, maybe we are giving some enclosure, operating gates, or some area scanner devices. So in this case, still there is a clear separation. There is no hand-in-hand operation. Robot and person are not sharing the same space at the same time. Depending on the nature of the operation which needs to be carried out, they will share the same space but at a different interval. When person is having access to the machinery, robot will come to a standstill condition. And when robot is operating, person will be at the safer distance or outside the enclosure. But now, in Industry 4.0, hand-in-hand operations are also possible. So robot and person will be working at the same area at the same time. So hand guiding, you may have seen some hand guiding operations in the robot, especially in the collaborative operations or cobot. So in this case, whenever we are using the cobot, it doesn't mean we are compromising the safety. Typically, we are maintaining the safety also, and we are maintaining the operability of the machinery as well. And hence, whenever scenario like man and machinery are working simultaneously at the same time, at the same space, we need to think of some innovative solutions, wherein maybe hand guiding solution, force guiding solutions, based on the connectivity, different product may needs to be used. So just as a conceptual, in a traditional way, we use guarding, interlocking switches to make sure that people are safe from the unwanted or unauthorized access. Whereas in collaborative operation, man and machinery will work in the same area at the same time. And hence, there is a requirement of a risk analysis. Whenever there is a possibility of hazard or incident, we should do proper risk analysis. So there is always a dedicated standard available. So for the risk assessment, what is the standard? ISO 12100, specifically with respect to the machinery. Okay, so this ISO 12100 standard talks about how you can do the analysis and estimation of a different hazardous scenario into the machinery. So there are certain steps we need to follow, like as a first step you need to identify limits of the machinery. It may be user limits, specification limits, different energy sources which you connect into the machine, electric, pneumatic, hydraulic, chemical, water, different type of energy sources are there. That sources itself can lead to the incident sometime if they are not controlled in a safer way. Then hazard identification. Simple, nowadays robots or AGVs are being used frequently into the plants. If robot is there, what are the different type of hazard associated with the robots? Simple, impact hazard. If you have access to the robot while it is in motion, impact is possible. Crushing hazard, clamping of tools or clamping of fingers due to the end effector. So all those hazards, whether it's a mechanical, electrical, control system, those has to be analyzed properly. And for this, there are some dedicated standard also. Like for risk assessment, I told you ISO 12100. For robot specific risk, if you want to know, there is a ISO 10218 series standards are available. Now, here once you identify the risk, you have to evaluate and estimate the risk and then evaluate it. To estimate the risk, what you can do? There are hundreds of methodologies available. Risk graph, risk matrix, multiple methodologies are available. Most of the popular methods are numerical based, like HRM, hazard rating number. These are widely used methodology to identify whether this risk is acceptable or not. Same way when we are doing this network analysis in industry 4.0. So there is a standard separate for the cyber security related aspect, that is IEC 62443. This standard talks only about the risk associated with the cyber threats. Okay, so in this you will be able to identify what is the security level required. Security level 1, 2, 3 and 4. 4 discrete levels are available when you want to have a cyber security related analysis. And once you estimate the risk, then you have to decide whether that is acceptable or not, and then that is a part of evaluation. So in this case, if your network is not safe, you have to do some risk reduction measures. Maybe you have to use a localized firewalls, maybe you have to use some other IT related equipments to make sure that network area is completely safe. If there is a control, typically whenever machinery is involved, control system is there. So along with the, whenever control system is involved, you have to use ISO 13849-1 standard to make sure that you are able to identify correct performance level, and for network correctly identify the security level. Nowadays, if you see most of the machines, I would not say there is even a 50% implementation of all the IoTs. Okay, it is still in progress. So as far as the European standards are concerned, so there is a machinery directive available. Now in the machinery directive, there is a scenario new technologies are not part of it, like IIoT, AI, ML. There is no information is not available, but these are the new technology and there are associated threats available with the technology, and hence to adopt these technologies, new regulation has been adopted. So there is a machinery regulation which will be into enforcement from January 2027. Right now it is already published, but there is an option available. Transition period is going on, so that transition period will end in Jan 2027. After 2027, it will be a mandate whenever there is a network system, AI or IIoT, proper analysis of all the security level has to be there, and that is as per the IEC 62443. So in this case, as of now, it is even if there is a loss of productivity, there are some static scenarios. if there is a maintenance error comes or machinery is into the shutdown, there is a loss of productivity. There are maintenance time which are required, and hence there is a limitation in operating and maintaining these equipment. Whereas in Industry 4.0, it will be predictive maintenance. Sensor itself will show when it can fail. It will give some information via some protocol. For example, IO link. That is one good example wherein lot of information will be conveyed, and hence before a system may trip and machinery come to a standstill, you will be able to identify this and make a necessary correction or take a necessary action so as loss of productivity will not be possible. And hence, to do all this activity, you need to use lot of network equipments. Modular certification is a part of Industry 4.0. Whenever you make any changes into the system, right now what happens, if there is a complete line or production line is there, which is controlled by one control system, if any new changes needs to be carried out, by which new risks are generated, your original certification is no longer valid. But when you have a modular structure in the machinery, if you are changing particular thing into the module, you don't need to certify entire equipment or entire production line. Only that particular module will need a recertification. And hence, this approach will change the way we are implementing the certification approach to the machinery as well. So modular certification, which is a good concept, rather than going or implementing the changes to the complete line, it will be a modular structure and changes can be done in structured way. So now, related to the security, like I said, the standard 6244 IEC 62443, this is the series which is more common in use whenever cyber security related aspect needs to be checked. And mainly there are multiple standard in this series, but IEC 62443-3-3, this is the more visible standard globally. This is the standard which gives information about security level and foundation requirement. So like I said, there are 4 security level, SL 1, 2, 3 and 4. There are again 7 foundation requirements for networking aspect. Foundation requirement 1 is related to the identification and authorization control. Who is assessing the machinery or equipment? Foundation requirement 2 is related to the user control. How in a modular way user control will be applicable. Then third requirement is a system integrity. Fourth is a data confidentiality, which is very important. And then fifth requirement is a restricted data flow. Sixth is a response, timely response to the malfunction or events. And 7 foundation requirement is a resource availability related. So this foundation requirement plays very important role whenever we are implementing the security level into the machinery specific to the networking. So when you are thinking about the standard or compliance, do not just think about the security level which is required. Think about the foundation requirements as well, that is from FR1 to FR7, which talks about identification to the network management to the data access. Of course, you see here, there are certain risks and countermeasures are also available. So when I say there is a chances of failure or interruption into the machinery, simple example, each machine has an emergency stop. What will happen if emergency stop fails? Machine will not stop. So how to counter this? Redundant structure. Rather than going with the single channel emergency stop, you can use a dual channel architecture. Same things are applicable in the networking also. If one failure aspects are there, then we have to implement the redundancy there as well. So if one channel fails, safety will be maintained through second channel, but it will not allow to compromise our network in any way. So we have to maintain that security level even if there is a failure aspects are there. So if there is a corruption in the data, loss of data, by using certain protocol, those data breach can be detected and certain actions can be taken. So in this case, multiple protocols may needs to be used. So as of now, most of the systems are fixed. There is a system, there is a PLCs, there is a SCADA, there is a PC terminal. But in tomorrow's you will find in Industry 4.0, typically you may need to use some AI algorithms, ML, cloud system. So whether it's a AWS, Azure, so data storage, mostly it will be done on the cloud, and based on this, access level will be given. So it is no longer a fixed connection. These are remote connected. You can have information just on the click of your buttons or fingers. And hence in this case, when we are implementing these solutions, please think of a standards compliance which is needed with respect to the networking. So if you do the risk analysis of these or security level analysis of the network, there will be high possibility that there is no chance of any security related threat to your systems. Now, in this case, there are multiple levels like components on the factory level, there is a network level, and then all your communication or network related equipments on the factory level. So interface with respect to all these level has to be secured. It may be intranet, it may be internet, there may be a different type of communication methodologies used within the plant or outside the plants. All those access control has to be secured by some mechanisms, and hence we have to make sure that whether it's a fixed installation or some dynamic situation, dynamic machineries, all the cases safety will be maintained. Now these are the foundation requirement which we talk about. So we have to talk about, take care about the data integrity, data confidentiality. In some countries it is already implemented and it is expected to be implemented in India as well. How the data will be managed, resource availability, identification and authorization control, IAC, that plays most important role. Nowadays some hardware or unique keys are being used in the equipments to make sure that this unauthorized access will be prevented. But as per the Industry 4.0, it will not give a enough amount of data like who is accessing these keys, and hence you may need to use some RFID keys which gives lot of information about security level, permission level, who is the person, their hex code or some unique coding by which person will be authenticated and known. So these are some foundation requirement over which networking security will rely on. Okay, now these are the some of the IEC standards which are available. These are all IEC 62443 standards. 62443-1 talks about the definitions and terminology, especially with respect to the industrial automation and control system. In short, IACS. Many times you may find IACS terminology is used, so it is for the industrial automations. Then there is another standard 62443-2-1. It talks about owner security and program requirement for industrial automation aspects. And then there is a 62443-3-3 standard which talks about different security levels. That is mostly talk about the standard. The purpose of informing you this, providing you this information is that don't just use security level related standard 62443-3-3. There is a complete series available which talks about complete network related aspects. So 62443-1-2-2-1, all those standards are applicable for the industrial automation and cyber security related aspects. Now typically sometime when we are talking with the factory people and IT people, terminologies are different, and hence there is a difference of understandings are also possible. Typically in automation, availability of equipment plays very important role because it is directly related to the productivity. And in IT world, confidentiality plays important role. Few days back, you may have heard the news that one of the MNC's data got leaked, their credit card related information and all got leaked due to the ransomware threats. So in this case, their network got compromised and confidential information like account numbers, user IDs and password get compromised. So to understand the depth of threat, analysis is required in detail. So SL1 means that there is no threat, while SL4 means that there is a high chance of threats, and threat may be used by the people who has multiple resources. They have the motivations, unlimited finance to do such activities, and in such scenario also network protection is required. So that is the threat level 4, that is SL4, which is there. Not for all industries it may be applicable, but sometimes SL2 or SL3 level can be applicable. So in this case, availability of equipment, confidentiality, liability, data liability, that will play important role. And hence when we are sending the data, it has to be through some safe protocol or safe conduit. So which type of protocol to be used? That information you can easily find in this complete standards. Now in this case, some solution may be to just use a firewall, localized firewall, but there are some industrial security bridges are also available as a standalone product which can be used in individual machines, and access to the machinery at the local level can also be prevented with the help of this security bridge. That product itself can give a protection of up to SL2 or SL3 based on the supplier's informations. And hence here, while identification of security level plays important role, and here you need to do the risk analysis as per IEC 62443 standards. So when security level 0 means what? There is no special requirement or protection needed. Security level 1 means protection against unintentional or accidental misuse is needed. SL2 means protection against intentional misuse with the help of few resources and skill sets. While security level 3 means protection against unintended use, misuse by sophisticated means and moderate resources. And 4 means intentional misuse by sophisticated means with extensive resources. Specific knowledge to the industrial automation is also available, and there is a high level of motivation available to breach the network. So in such cases, SL4 can be required. So these are the main challenges with respect to the networking. So while taking into account safety and security, planning of networking plays important role. Also, the type of equipment and devices used in the machinery, what type of connectivity they are having, they play important role. So in this case, there is a huge requirement to meet the security challenges, documentation related to all the IT related component, do the risk analysis of all equipment, creating the IT infrastructure, creating the IT security related directives. From that, your analysis will start. And then only with the help of trainings, then with the help of actual implementation and learnings, you will be able to know what are the actual risks into your system. So just as a summary, safety and security, they are two sides of the same coin. Safety plays important role as well as security plays important role into the machine automations. So based on the demand of the machinery, solution can be a complex or sometimes easier solution can also works. Best way to make sure that you are having a system which is meeting the requirement of the standards or directive. So you can just use the recommended IEC or ISO standards, so that you will also knowing that compliance level for your equipment or network is achieved properly. And very important role, just product alone cannot guarantee you safety and security. The way they are configured, the way they are being used, that plays a very important role while implementing it into the industry 4.0 scenarios. So main standard for identifying these is a 62443 series. With this, I will just play one small video which is a smart factory concept. This is the one industry 4.0 concept developed. So there is a machine available. It's a complete
Smart Factory from Pilz. Here, pens and business card cases are individually engraved. The Smart Factory is composed of 3 modules which are networked together and can operate independently of each other. Once the engraving data has been entered into the computer and sent to the Smart Factory, production in accordance with Industrie 4.0 begins. An RFID chip on the workpiece carrier contains all the data relevant for the process. So the robot in the second module knows whether it needs to remove a pen or a business card case. The laser in the third module engraves the workpiece using the stored data. The result, individually engraved products at will. The Industry 4.0 compatible automation system PSS 4000 coordinates the sequence of all networked components, safety and automation, from engineering to visualization. If an error occurs, it's displayed immediately on the PMI via the web-based visualization software ParsVisu and can be rectified. In addition to these products, this smart factory uses all automation products from Pilz, from the sensor and drive through to the controller. We'll be glad to use our expertise to help you work towards a smart factory with tailor-made automation solutions. We automate for the future, for Industrie 4.0.
So all these modules, 3 modules are there, all decentralized. Each can be disconnected easily, again reconfigured easily. And all the security related aspects are also covered while implementing this as a standalone solutions. Okay, so with this I will end my session. Thank you very much. Let me know if you have any questions. No, this factory is not installed in Pune, but yes, conceptually the technology which is available, some of the products you can see in our stall also, and some products are in our office in Pune as well. Complete factory is not installed in India, but the products which are there, those are installed as an individual solution in multiple factories. That is used. Yes, in Pune itself, it is used in a Chinchode, Ranjangaon, multiple MIDCs, it is already used. Yes. Okay, thank you. New technology will come. Name may be different, okay, but it will be called as the same name. But yes, the talking started, discussion has started, but I would say implementation level is still there is a talk. Implementation has not done. Research are going, that is what. Shall I disconnect?
Thank you, Dheeraj sir, for the wonderfully explained session, especially with regards to safety, security, and standards. I would now like to call upon our second speaker for the day, Mr. Ravish Kumar, Solutions Head of Private 5G and Edge Cloud at our silver category tech partner, Airtel, for the session on building ecosystem for smart manufacturing with Industry 4.0 solutions. Mr. Ravish is an Industry 4.0 solutions expert with more than 15 years of experience in the field of industrial automation. He has made significant contributions in technological innovation, has filed 15 patents, and has published many research papers. Sir, please do take over.
Hi, good afternoon. I think you have seen this slide. If I remember, the industrial revolution was already covered, right, in the previous session. So I don't know, like I skip that. If it's covered, then I will skip it, or maybe I will just. This is shown in the previous slide. Okay, then let's move. Okay, so in this today's session, what I'm going to cover about. And like from our side, from the Airtel side, what we are intent to do, okay? And I would like to have this session to be more interactive because like a lot of things would come which will be good for maybe you can you may be interested in, right? So this two picture you can see there, right? Industry 4.0 revolution, you see before that whatever the industry was there, hierarchical looks like this, right? It was pretty much the the hierarchical layer there, the bottom layer is the field devices, the top layer is about control devices, and the information flows from bottom to top and top to bottom. Now, problem with this one is that this was good enough. Like in one plant, it was working fine, pretty much controlled, everything was fine. But the problem was when the plant got increased, number of plant got created in different site, when the information need to exchange across the plant, where more participants came in the picture, where more data was coming, then this hierarchy was not working at all. Handling capacity of data, analytics application, all this thing was failing there. That is where the Industry 4.0 came. Now, Industry 4.0 world, everything is connected. Sensor, then you have controller, whatever device, application, everything is connected. And whenever everything is connected and think about it, it is being called smart, right? So here everything, like whatever the bottom layers are there, which is generating a data, thereafter all the data how is being utilized and all this thing is like n number of things are coming off, right? Now, now one more thing yet you have to see, that is the reference architecture of Industry 4.0. Then I will talk about like how this architecture we can understand from our purpose from the technology point of view. What you see that is the bottom layer is about asset, physical thing. So whatever smart device and all this thing, you need to connect with the physical world, and then this data need to transform to the digital world, right? For that purpose, you have the asset and integration. These are the existing thing. Now, other layer like communication, information, function, business is the new addition, the additional layer, how it's built on the Industry 4.0. So when you say the information, it is more about the contextualization of information which is coming from one place. For example, in this room, right? Some people speak Marathi, some people speak Hindi, some people, different languages are there. But the point is that how we are going to communicate. It has to come into one platform that people can understand. And this is where the contextualization of the information, taking place, right? So contextualization means like whatever the format you are that generating the data, I should be able to understand the semantics of it, and the application should be able to understand the semantics of it, and application can be developed, right? Now, if you see this one, right, where there are two parts are there in this diagram. One is the real device, and the second is the digital world. When I say the digital world, it more talks about the intelligence, analytics, and other stuff. And if you see that whole industry 4.0, if you try to simplify the complex architecture in the industry 4.0, you will realize two things here, or maybe three things. The first thing is the real device. The second thing, we are talking about connectivity. And the third thing, we are talking about something which will work with which require computation, which require storage, and which require analytics, right? Now, see, we are saying the smart connectivity. The connectivity is more important. It's the basic enabler for any kind of digitalization. If the connectivity is not satisfying the requirement of the digital application, whole system will collapse. It will not work, or you cannot dream about. So connectivity is the key piece here, right? Now, if the connectivity is the key piece, let me emphasize further to understand what connectivity is, right? So there are 2 points in the connectivity. Any connectivity you take it. Again, I'm trying to simplify the topic so that the basic fundamental things can be understood. In the connectivity, there are 2 parts. I'm without mic, I'm audible, or should I use a mic? This mic. Right, so I will just leave this. So in the connectivity, there are 2 parts are there. The first thing, how far I can communicate. The second is how much volume of data I can communicate. One talks about the bandwidth. Second talk about the range, how much we can communicate. 2 fundamentals, right? Now in this diagram, what you see that is there are different technology in the communication. NFC, near field communication, Zigbee, Bluetooth. There are proprietary communications are there, Wi-Fi is there, and then we have low data rate communication, which is LoRa. That communication comes in a picture, and then we have a cellular network. Now here, point you noted that if you see Wi-Fi is having high data rate, but the range comes in 100-meter area, or maybe 100 meter. But when it comes to cellular, the communication range is very high. So what happens till now is that in a plant, who needs the mobility. Okay, this mic. Maybe I will use this mic. Yep, this is better. Okay, we try this time. Hello. So yes, so there are 2 parts which I talk about. So Wi-Fi. So what happens till now is that if you take example of manufacturing unit where a lot of devices and equipments are there, which is moving around, the wired line doesn't work there. Okay, why it doesn't work? Because wire does not provide the flexibility. Till now, wherever the flexibility required, you don't have any option to use other than Wi-Fi. Now, the problem comes with the Wi-Fi is that it cannot satisfy your control requirement. It was good for the monitoring purpose. It was good for some kind of where the real-time things are not required. But a lot of attribution was there. People have implemented, but they struggle a lot in terms of management, in terms of satisfying the range and other stuff, right? Okay, so from Airtel point of view, like what we are, at least when you say the connectivity, so we are taking care of the Wi-Fi and the cellular network. But here the keynotes you need to understand that is the cellular network sits on the top right corner, which is high range and high bandwidth. Okay. Now, for the digitalization, I'm again trying to simplify this story that, again, from the connectivity point of view, how it looks like, is that you will have a plant, and that plant can be located near Gujarat. And other plant, the same company plant is there in the Mumbai region, for example, and then Delhi and then Bangalore site, right? Now what happens is that you need a communication within the plant, right? Then second communication is required that between the plant, right? So, yeah, so what solution we have is that uh, within the plant, if you need a communication, mobility communication, then the private Wi-Fi, private 5G is the solution. Now the question is that why private 5G? What it means, what is the private 5G? I know 5G, but what is the private 5G, right? Private means it's yours. Till now, whatever mobile communication we are using it, whatever network we are using it, network we are using, and we are making video call out of it, all these communications are shared. You can understand in this way that if you have to come by road, the road is shared road. 5 o'clock you come, you get high speed, 5 minutes you can come, morning if you're coming. But if you come at 10 o'clock, you will get 1 hour. I don't know how much time it will take. The other side of the story, if you see, if you have a metro, whether you come in the morning and evening, anytime, you have fixed time. The reason is that you have reserved path for the metro. No other vehicles are allowed there. While in the public road, anything can happen. Same philosophy is there with the private 5G and the public 5G. Private 5G is for your communication. Now, since you know that this is the amount of time is going to take, this is the private 5G, then you can design your application based on your need. In the industry, the important thing is that I should guarantee my communication, the machine to machine communication should happen within that time. If the communication failure is there, the information failure is there. If the information failure is there, machine will not able to make decision, whole system will collapse. For the machine, important thing is that information has to reach on the right time. Then the whole ecosystem of machine works. Okay, so now in this story, you have seen that the private 5G within the application, on-premise, whatever applications are there, that can be managed through the private 5G. And then within the plant, if you need to communicate, again through the private line. So we have MPLS network, which is the real line. How it works is that whatever the red dot you are seeing, right, that is our data center, edge data center. And our data center, each of our data center is connected to reliable communication backbone. So the philosophy of this works is that if the plant is there in the Mumbai and it has to communicate to the Bangalore, then you will take a lease line from us. And then what we will do that is we will connect the Bangalore. Yes. Hello. Okay, so we will connect the Bangalore one with our nearby edge data center. And then from the Mumbai other data center, you can take out the data. Point is that it's a backhaul network, whatever we have it, and just the edge point need to be connected. You have complete private network in place. Now, other part of the network is that you will have a lot of mobility devices that need to communicate. For that, you have different IoT solutions. Okay, so now this is the the story of the complete communication thing. Now, when it comes to the private 5G, like you have seen the Industry 4.0 revolution, the similar like in the cellular network, we have a revolution for the connectivity. So what you see that is the first phase of connectivity started with 1G, we are saying. We need to understand one thing here. All of us electronics and company, basically we know we are engineers, right? So everything is, to have it, we have technology backbone. When the first G generation started, that time only the analog devices communicate. So analog devices, what was happening that we was doing the frequency level modulation and then we are sending a data. That time the communication was taking place, but no digital data was there, right? So that was the first, and that we use in the military purpose of the communication. The second, the game changing happens from the 2G point of view. That time we started with the SMS, if you remember. Mobile was there and we are able to send the message, and we was very happy that apart from the communication, we can do the SMS. But that was digital thing that happened first time. Now, if you remember the third phase of the mobile communication, where we was able to download the video and we was used to watching the movie. And we are happy with that. Nobody asked that, okay, why we are downloading and all this thing. Every time we were downloading it, all the movie, everything. But now things have changed. We are not downloading. Now we are talking about streaming it. The downloading word is gone out. We are not downloading. We are Amazon, just watch it. This technology change has happened with the 4G, where we got high-speed communication bandwidth. Now we are talking the real-time gaming. The person is there in the different world. They are gaming lifetime. It's good for the, if you see from the user point of view, yes, we are doing that, but you need to understand how it got enabled because of the communication backbone. I mean, it's just like you have a super hit movie, but who has worked for it? People don't remember, don't know. But as an engineer, we should know that how it is enabled, right? So that technology was 4G technology, which allowed us to do that. But till now, the 4G was able to do such thing. Then what was the need for 5G? See, so every technology is having some limited reason why it has to come out. Now, in the 4G technology, if you see, it was having good bandwidth. You can do a real-time video, everything fine, but it was not suitable for industry. It was good for the normal customers, like normal users, I would say non-real kind of scenario, because the traffic in the 4G is always best for traffic, right? Now, the era has come for the 5G, and symbol-wise, you can see it's a rocket, right? So the point is that in the 5G, we are able to provide ultra-low latency. And it really means a lot for the industrial application. It means a lot. See, in industrial application, you have the real-time control loop. And decision has to be taken in the millisecond. For example, if utility, grids failure happened. There's something called Goose protocol works there, and it has to communicate over 1 millisecond or 2 millisecond delay. The communication speed should be faster than electricity. On time, if you are not switch off the grid, the other grids can collapse also. So the importance of communication speed is very important, right? Otherwise, system will collapse, right? So there are different kind of applications, different kind of systems are there. Communication requirements are different, but the need of communication and then requirements has to match with the communication things, right? Now in the 5G, what the key things that you need to understand, that apart from all the feature, whatever you have seen, the 1G, 2G, all three, in the 5G, we have ultra low latency, enhanced mobile broadband. Latency defines that how short you can communicate. My message is confirmed, like reaching there. Now the bandwidth, enhanced bandwidth, how much data I can carry, whether I have a tempo truck or I have the 612 truck, like to carrying the data in the same road, right? Now the third thing is spectrum slicing. I will come to that. And the fourth thing is the massive IoT. Now this spectrum slicing is what, right? So it's just like, you can say that you have 10 lanes road, which is the bandwidth. You allocate that one band for truck, one band for this, one band for this. This is how network slicing works. I have a bandwidth and I am dividing this bandwidth for this purpose, this particular purpose, so that nobody can come across to each other. It's dedicated for everyone, for the particular thing, right? So just to give a glance there, that the communication related standards are defined by an organization which is called 3GPP. And this technology, the standards is being defined in 2019. And the need was there, the most of the requirements for this particular standard come from the Industry 4.0. They were saying that we wanted to build a dream for digitalization, everything has to be communicated. And this research has gone where need to understand how that can be enabled. If you read out the reference architecture and the vision of Industry 4.0, if the 5G doesn't come there, then the story is incomplete. Same way, this particular things like industry. So normally how the standard works now. So one people will define the particular thing, and then it is divided. The other committee will communicate with other kind of supporting technology, and they also work parallelly. And all together try to come in the different same time frame to enable this particular ecosystem. So 5G is the product of the Industry 4.0 vision. One way, if you say that's not, it's definitely correct. So 5G offers, as I said, enhanced broadband, low latency, and massive communication, right? Now, this just for the information, right? Now you understand the importance of 5G, right? So just understand that how the different kind of philosophies are there when the solutions are being deployed, what elements are there, very high level. We don't need to go in very complex, but just to understand. In the 5G, if you classify the 5G, I say there are only two components. One is the radio access network, second is the core network. Now, what is the radio access network? Radio access network takes care of the radio communication. Whenever information is there, it will go through the radio and it will reach to one point, which is called packet core. And from packet core, you can divert your network anywhere, right? It's just like channelizing thing. Now, in the private 5G, you have a different deployment option where the packet core and radio can be in the premises so that you have whole control of your network. The second scenario is that because the packet core is the costlier operation, it's a brain of the Wi-Fi 5G, right? And in order to handle the brain, you need the space, or you need infrastructure, you need a skill set to manage it. So there are different philosophy of deployment of 5G are there, and this based on the application to application, this can be there. So one is the isolated mode. The second one is the hybrid mode, where what you see that the radio will be there in your part, license would be your part, but the decision will be taken care by different places, like that the core is residing in the mobile network operator. That's the second one. The third one is the sharing model, where the same radio can be used for the private, half of the things can be used for the private purpose, and half of the use for can be used for the other purpose, and the core can reside in the both parties. And the second, third one, the last one is the hybrid one, where one radio can carry both information and all the things are residing into the mobile network. So I don't want to go in detail. This is much technical part, but just try to understand that different applications. Say for example, in this application, what will happen? If this is my plant, and if in this plant I'm putting my radio in the core, then I cannot manage other plant, right? I have other building where I need to manage my network. I cannot do that. So then I have to go for different mode, where core I can put a separate part and all the plant data come there. So there are different philosophies are there. And then one important thing, this one is some trade-off, like some analysis are there. Like I told you, right? The before 5G, or even as of today in this building also, Wi-Fi is enabled and it's working, right? But okay, for internal purpose, for small purposes, okay, if the packet drop and all these things are acceptable. But in the plant also, they don't have any option, they are using for Wi-Fi. Now, if you do a comparison that latency-wise, reliability-wise, mobility-wise, coverage-wise, everywhere, 5G is getting good score compared to Wi-Fi. So it's natural things are there that people will start shifting to this communication one by one. Now, from the network side, technology side, I think telecom operator like Airtel, they have taken very aggressive approach to deploy the deployment. It's just like, you know, to build a good nation, you need a good infrastructure. So government, what they do that is, first they develop a good road. Automatic transport will start, business will start, everything. So we have laid down the road for the network, for the private, for the 5G. Lot of other application things are coming up, and it will come up. So this is like the area which is going to be innovate, which is going to be a game changer for the digitalization. The power of 5G is very high, right? Now different application and all these things need to be developed. So near, you can say, you know, near to maybe 2 or 3 or 4 years later on, you will see the application which will come with the virtual reality, augmented reality. You know, all these things comes in a picture because those applications require high bandwidth communication. Till now, it was not possible, but with this one, it is possible, right? So in between, if you have a question, definitely you can interrupt me. One more thing, I will emphasize that about the access, multi-access edge. Okay, so just given the example here that, right. So if you see this example, so what you are saying that is, there is a device A and there is a server B, right? These two devices has to exchange the information, right? Now, how the information being exchanged? This device will talk to this radio. Radio will go to the core, and core will decide which is the destination packet. Then again, it will transfer to that nearby radio, and then packet will come there. So if you see in this scenario, if I combine the time frame, the network latency, what it comes? T1 plus T2 plus T3 plus T4. What is the value of T1, T2? That's a different thing. But these 4 elements are there in the communication. Now, if this is the server application and this is the client application, so you can see the latency are having 4 components. Now, in the 5G mode, we are having a network edge. Okay, So thus network is what it works that behind the core network, with the dedicated line, we are providing compute infrastructure, kind of cloud you can say, where you can host the application. Now, if you host application behind the packet code, your latency is just half of it. What you are from anywhere you are sending the information, and it is reaching to packet code to this one is verified. So now it's possible that you can further, like with the network application play, we can further define the low latency here, and we can design application which really suits for your, for example, the control application. Even on the cloud, we can put a device there in this one, data communicates there, and all the control action taken in the cloud. So those kind of scenario also can we think about, right? So this is the network edge, the component that is newly cloud component. Next slide I will say where it fits actually. That is there, right? Now I will take you for some of the interesting yeah. So this network edge I said to you, so then I will show you where is, okay, so let me go by this one. Okay, so here the 5G application solution overview, if you see that there are different applications which is now targeting for 5G. One is the automatic guided vehicle. Now this is taking place in the production plant in the heavy way. Why? Because see, if you see any production plant, like if for example for the Kirloskar Kavel plant, they have the warehouse where they are manufacturing the big engine. For each engine they have to manufacture, the different component has to come from different warehouse, and this component need to assemble there, and whenever the batch comes, this component need to pick up from different location, and it has to go in a different assembly line. Then this component are assembled together, and then whole engines are manufactured. Now in the manual operation, the problem is that where is the part of assembly is kept there, picking that part, and then again reaching to a different location. It's a manual effort. Now some digitalizations will be taken care for sure. Now this particular things can be handled by automated guided vehicle. So this vehicle, what will automatically, it will pick up the device where it has to reach, what time it has to reach, automatically things can be taken care. Now for this automated guided vehicle, what do you need? Communication, and that can be enabled with the 5G. So you can see that the application which is coming up and how the game is going to change in the plant. It's all things are, it's a completely, a lot of new things will come. That's what now the connected tools we are talking about. We are talking about the rail mount gantry cranes we are talking about. So different tools are there, different applications are there. It has a connectivity 5G, and then when the wireless network, like whatever RAN things are there, which is having a backbone with optical fiber, and then things like that, it works, right? Now just a glimpse of different application again. For like if you see the ultra low reliable latency, right? Whatever the communications are there. See, for example, the public sector, remote surgery. These are the applications where you really need low latency requirement. Yes. Okay, so I have 5 minutes. Okay. Yeah. So okay. So then what I will further, I will just quick around wherever the slide things are there. So this one you have seen. Now other part, yeah. So other part of the solution is about the IoT edge, right? So now what you have seen, that a lot of devices are there which is connected over SIM card, billions of devices connected to SIM card. Now the question is how you are going to operate the SIM. For that you need a platform, right? So that's the platform is managed by us, that we are providing kind of services. Now the data which comes from the SIM card and all this thing, what applications can be developed? So we are having the analytics application which talks about the predictive maintenance and other stuff, right? I will quickly, this slide I wanted to show you, that if you see right now, if people talks about only 2 things they talk about. The first thing they talks about the on-premise solution. Second things they talk about the cloud solution. 10 minutes more. Thanks. I hope the session is interesting. Otherwise, I can sort it off. Yeah, yeah. So till now, whatever you have seen that is that there are two kinds of scenarios are there. If you say I want to design application, people will ask two questions. It's on-premise application or cloud application, right? Cloud means public cloud where the AWS and other things are there. On-premise in the premises one. And if you see the communication latency, so if you have the on-premise and cloud, the advantage is there. Of course, they are like management, all these things are there. But from the communication point of view, the latency it matters. In on-premise, you have low latency. Cloud is high latency, right? Now the third picture that is coming up is this one, the network edge. I remember I showed you a slide where behind the network you can put the edge. So this is the network edge concepts is there where the operator, like telecom operator, can play nicely. So what we are doing that is like you have option to on-premise where you need a low latency, fine. But you need to manage your all the data center, everything is your headache. Failure is your headache, data backup is your headache. Okay, I don't want you to have it. Then go to the cloud, now latency is high. Then you come to on the network edge. So network edge is like we have a data center, the diagram which I have shown you red dot. And each of the data center is built where the norms are there, right? The norm says like data centers power failure should not be there. Power comes from the 3 gate. Whenever earthquakes are there, nothing should happen to data. So there are different norms are there. And that particular data center developing by any company, it's a big game. They cannot do that. Huge investment goes up. So whatever data center company carries is a simple server with AC and all this thing, but it is not having the 3-grid power supply and other stuff. So with our solution, if you see that the same level of data center near to their solution can be achieved through edge network solution, right? And this is also going to be a kind of game changer where a lot of requirement where the AR, VR kind of thing, the video analytics kind of application requirements are there, where you need a GPU kind of thing. The hosting the GPU in your on-premise is a heavy operation, and sometimes you don't need always, based on the need things, right? That can be rented out. So in data center is good for the hosting GPU, where the live amount of data goes from the plant, and you do a video analytics and other stuff comes back in the real time. Right? A lot of new use cases are coming up with the edge part, right? No, it will be lesser than that whatever the hyper cloud costs are there. Okay, so it's like this hyper cloud cost is pretty much higher side. For example, I'll just tell you that if you buy their IoT hub, okay, one component you have purchased, then you have to buy subsequent component to build the application. You cannot go here and there. Here, whatever you need it, the data has to reach there. So cost-wise operation, we have done the company, our cost is more on competitive, lesser side, but you have low latency there. And data is within the Indian premises. Cloud, when it comes, of course, you have to, like where the data hosting, I mean, of course, they have also the kind of scenario you can make the agreement there. But this is the important thing, the data is near to your location. So if, for example, if you are there in the Pune, you wanted to also, we can host your data in the Pune data center, nearby Pune data center. So that's very close to you. I answered your question. Yeah. So. Thank you. So what I will do that is quickly I will show you some of the use case. This is more interesting part. So we have done some 5G trial, and in this trial, what was the requirement was like this, that in the automobile manufacturing line, what happens is that they manufacturing the vehicle and they put in the yard. Before delivery of particular vehicle, the ECU need to be flashed. And ECU is basically, ECU is like engine control unit that has to be flashed before delivery. ECU, the software is very critical for the automobile vendor. It's their IP. The software should not be loose outside anyway, right? Now, in order, till now what they used to do that is that the vehicle is there in the yard and it is like, what do you say, one is in the queue, like last in, first in, last out, right? That kind of queues are there in the yard. And the vehicle is there stuck. The vehicle who is coming new, that is picked up assemble, and so on to the customer. The old vehicle is still there, right? So now another problem is that this particular area where the issue flashing is used to take around 1 to 2 hours kind of thing, and there are a lot of queues was there in the manufacturing going out. So right, so what we have done that is that we have demonstrated the capability of 5G, that in secure line you can transfer your software to yard, wherever the yard things are, there only you can flash it. So in this example, what we have done that is, they have the network, we have taken out the network, their data in the very secure way. And this plant, this particular 5G was there in the Mumbai office. From there, this data is routed to the plant area. From Mumbai, if the plant is there in the Pune, from Mumbai it's coming, and issue flash happened, and we got lower latency and Wi-Fi. So result, we got it. So if you see the result, that from 20 seconds to 2 seconds overall time we have saved it. Okay, flashing time reductions also happen, and it was very successful, I would say, kind of scenario where we have shown the capability of 5G. When the high bandwidth is given to you, what you can do that, right? The second use case is it's more over the use cases which people are talking about. I'm just bringing there how it will help it. Like, see if you see any plant, it's always outside remote, because the land cost is less. There is a number of reasons why it has to be remote area. Now, if those kind of plant, if the problem comes from the company to sending the site engineer, is a big pain. They won't come immediate, number one. If they are coming, logistics are a problem and all this thing. So this is where that, the one use cases are the AR assistant based, the maintenance, where in the plant, a skilled person who is operator, they will go there, and the operator is seeing the live information. It will instruct them, do this thing, and problem is solved. No need to move the time. Why it was possible? Because real time he is able to tell when and what need to be done, right? So this is one example of the use case where AR assisted maintenance can be done. The other use cases is also very interesting. That is not in India, but other side of the Europe, people have already done such kind of thing, where their machine vision AI for maintenance inspection. So there is a plan where you have leakage of pipeline, abnormal noise, and there are different kind of, the symptoms come, surface temperature is getting increased, and all the symptoms come. So the camera is installed everywhere, which is AR and temperature, infrared camera and all this thing, which will monitor all the different plant hotspot. And real time the data is being communicated, and you know that this plant is having this kind of problem. So this is having a lot of save. Why? Because you don't need to put a lot of sensor every place. You are scanning the temperature, scanners are scanning the data, understand the data, understanding the behavior. This is the normal range, it's going up, down, and immediately you say this is looks to be a problem, attend it. So very nice way that technology demonstration happen. Then the operation on the digital transformation for the mining. This is also very important area. This is also where the 5G is required. See, open pit mining, what happens if field are open, a lot of vehicles movements are required. Communication will not be there because very remote place, and how the vehicle and things are going to coordinate and all these things. So this is the area where things works. And one of the things we have done for the connected ambulance, this is the applications I think is running, where the ambulance was having a 5G connectivity. So patient will be there in the ambulance, and it is connected to the private 5G. On travel, the doctors are telling them, the operator, what need to be done, do this thing, that thing. So the patient life is safe, even if it's coming from the remote place, and it is connected, what to be given, everything is monitored live, right? So this is the kind of things as done. And 1-2 slide more I will show, and then we will end up the session. So one more things you can see about so this is about the IoT use case. So our IoT devices, basically we are providing a device which monitors the generator, the real diagnostic in the real time, the fuse and whatever maintenance things are required. So this solution got developed, and in this solution that Airtel IoT technology is being used, and it is deployed where the real time informations are coming based on the incoming data, that we are able to predict 30 to 40 hours when the maintenance is required. If you are able to in the plant, if we are able to do a prediction of the failure, you're going to really save a lot of things. Yeah, some of the things are there. I think I have 0 minutes left, so I have to stick to time. Thanks a lot for listening to the presentation. Thank you.
Thank you, Ravi sir, for the session connecting two very relevant concepts today, 5G and industry. We'd like to request our next speaker, Mr. Himansh Jadhav, CEO and Director of Jendamark India Limited, one of our silver category tech partners, for his session on a human-centric approach to smart manufacturing. Yes, after the session, we'll have a break. Okay, sure. So we can rejoin after 5 minutes.
10 minutes?
Where's my presentation?
Yes, so you attached your pen drive, or was it already on the system?
It was on the pen drive. What's your pen drive attached? No, this is not my pen drive.
That's not your pen drive, sir?
Here, this one.
Okay, this one. Yes.
Hello, good afternoon, everyone. Is my voice audible? Backbenchers at least. Perfect. I know it's a long day and afternoon sessions normally get very extremely boring. So I'll try to keep it as exciting and as controversial as possible. I think that controversies normally excite people. That's what I have seen in last few days. I actually, when I came today and when one of the questions which I always have had for last 1 year, and that's the topic of my presentation, is C4I4. It is Center for Industry 4.0. And I hope at the end of the session, at least I can convince the audience here that we should not call it C4I4 going forward. We should call it C4SM, like Center for Smart Manufacturing, because I strongly believe Industry 4.0 is not for India. Okay, so that is what my theory of my session is going to go around is, can we change C4I4's name to C4SM? So that should be the thought by the end of the day, that maybe we are in the wrong place. But anyways, let's go forward before I make more claims. Who and what we are. Let's get the guys to settle down. So, Jendamark is the company which I represent right now. I'm the CEO for Jendamark India. So we are a company established in 1989, 650 employees, 3,500 plus projects done in automation projects. So we build assembly lines, machines, 4 offices in the world in South Africa, India, Germany and US, and around 200 customers. Our main business areas are automation, Odin manufacturing, software solutions, and Odin digital. So today the presentation is of Odin manufacturing, which is primarily a software solution developed by an automation company to solve manufacturing industry's problems. And because we realize that the manufacturing world does not understand our world, the manufacturing world does not understand the software world, and the software guys don't understand what we want, and they create their own thing. So eventually we said, okay, after 5 years back, we said, okay, let's hire software developers and make the software which we feel over last 34 years of experience of building machines, what actually the manufacturing industry needs. And that's how we went on this journey of creating our own software. So that's our facility in Pune. We have office in Chennai, Bangalore, Delhi. A few of the credentials which I'm very proud of. We built India's first battery pack line, India's first commercial vehicle motor line, catalytic converter line, software division, Boeing Defense, first factory of future, and our average age is still less than 30. So these are some of the credentials which I would like to initially state, so it builds some credibility to what I'm speaking. Otherwise, they might say, why are you talking about? No. So that's the credibility which we have established over last 5 years. These are my reputed customers in India, in automotive sector, which you can see the big names in the powertrain, Volkswagen, Skoda, Ashok Leyland, Mahindra, Audi, Kalyanis. So almost most of the automotive companies which are in India, Indian and non-Indian, are our customers. Software solutions which we have installed outside are already used in all these companies. Again, you can see a good mix of Indian and non-Indian companies. Electric vehicle companies are our current, let's say, the front runners in our business right now. So that's what we have been busy with in the last 7 years since Jendamark came into India. Right. So now let's start. What is digital transformation? I think many companies approach us and they start telling us that we would like to transform our company digitally, make our company smart. And I think it was very good when Mr. Rahul Kirloskar mentioned in the morning that start with something small first. Don't go with a big bang. And for me, digital transformation is a very big bang. First step is not that, but hello, yeah, is first step is digitization. So before you talk about digital transformation, digitization, which is basically change from analog or physical to digital. So a lot of us, it is like that? Okay. Yes. Maybe I can stick to this. Not yet smart. Yeah, exactly. That's why you say machines are not as smart as humans are. So yeah, so digitization is something which I believe is a first step. Then you automate the process. So, typically we started moving from in around COVID era, we started scanning barcodes. Till that time, no one scanned a barcode and nobody knew that what is barcode scanning and how now we are transforming. And in fact, even outside, if you see, we have all paid for lunch or coffee or something by scanning a barcode. That's the first step. Physical analog hard cash was transformed to a digital process. Then we came to automate process, streamline process, which is basically digitalization. So first go from analog to physical to digital. Then second, go to digitization, where you're using technology to transform the manual process, which means now what you are already doing is in this process, which is now done with, instead of manual, with automated. And last is transform the business. The problem is people start with the last. Let me entirely make my entire process digital transformation. I want to transform my factory digitally, but then when you see that they're still giving coupons for lunch, how does that make sense, right? You can't transform a company digitally when you're giving coupons, hard copies for lunch. Start from there, where you give barcodes where people can scan and get deducted. That's the first approach I wanted to just talk about, that this should be the journey of any company which goes towards that. And then we can talk about AI, ML, which unfortunately the buzzwords get picked up by the industry CXO levels, and they will go and tell the shop floor, I want AI. First transform, first step for digital stuff, right? Anyways. So that's the brief. So now I wanted to talk about our topic, which I said that maybe in the end we should now think of transforming C4 I4 into C4 SM. The reason is Industry 4.0 is a fourth industrial revolution. That's what the I4 represents. Now there's already, which was actually something which started in 2010. So Industry 4.0 started in 2010 in Germany. 2020, we all know the world came to a standstill with COVID. That is the time when I'm sure every one of us in this room had some or the other effect, right? Something somebody felt in your mind, in your heart, which transformed you a bit to think of what are we really doing, what is our purpose of life, where we are heading towards. The reason why I'm mentioning is this, because all the industrial revolutions from 1 till 4, everything was centered around only one thing, which is do more. You see the first revolution, mechanical process with steam and water power. Second was electrical. So when you had steam and water, maybe you could do 10 parts a day. With electrical, you could do 20 parts a day. Then came PLCs. We said, okay, you can do now 40 parts a day. Then fourth revolution was smart IoT, where you don't need people only. You can do still more with less people. So every time the industrial revolution has always focused on do more. Whatever you do, less humans, do more. Right? That's the idea behind less human intervention, less human effort. Just keep doing more and more and more. Because that so-called improves the efficiency of the process, which is fine, which is correct. I think COVID made a lot of people realize that's not right. We are not a greedy human race, which is only wanting to do more, more and more. At what cost? Why should we keep doing more? And I mean, I give an example always of e-commerce, Amazon. Earlier, I used to go, if I had to buy a shirt, I would go to a shop. I would select the kind of shirt I want, try it, buy it and then use it. I would buy one shirt. Now, I buy 4 online. 4 come to my house, convenience. Maybe I need only 1, but because now I've got 2, I keep 2. Did I need 2? Because now, but somebody delivers 4 to my house, so I'm happy to have more and more options delivered to me. But do I really need more than 1? Never. Most of the time, we have always ordered stuff which we don't need. But then now who will go to the hassle of, because they make the hassle process of return and then credit into your account quite complicated to make sure you don't return only. So that is where I feel that this greed of wanting to do more and more had to stop at some point, which COVID made a break to everyone, and whatever happened during COVID made people think and realize maybe we should stop and we should think really what matters. That's where the 5th industrial revolution, which is why I said that I4 maybe should change to something else, where we said it should be human-centric, right? Now I'll go to some basic questions again. Is 4th industrial revolution, again my question was it for us? Well, I'm already using the term was, because in my head, Fourth industrial revolution is over. We should think of fifth one already. So this is the Industry 4.0 term which came in 2011 in Germany. Many of you may know already that Industry 4.0 did not start in India, did not start in US. It was specifically in Germany when the German census, which is the report of their population and the age and everything came out. That's when the German government called all the big companies like ThyssenKrupp, my colleagues from here, guys, this is a problem we have got in our country, in our economy right now. There were a lot of problems which were highlighted, and I'll show some of those problems like aging population, less resources to do what they wanted to do, the IQ level in general, what they were doing before, and now immigrants coming in. There are a lot of problems which German economy had, which came out in the 2010 census. So they called the big German companies like Siemens, T-Systems, Bosch, and asked them, this is what we are having. Please work together to find a solution because we would like to continue, which we all know famously, German engineering, right? They came up with these solutions: autonomous robots, simulation, system integration, Internet of Things, cyber security, cloud computing, additive manufacturing, AR, big data. This is what was the outcome, which is there also documented, and they hired BCG, that's Boston Consulting Group, who did a complete report for the German government on under the guidance of these companies. This is what Germany must do, Europe must do to fix its problem. Now, I would like to show the next slide. Are these appropriate for us, right? Now, here are some statistics. Germany's population is 8.3 crores. India's is 140 crores. Maharashtra is 12.3 crores. Area, Germany is 3,57,000 square kilometers. India is 10 times of that. Maharashtra is at par with Germany. Just Maharashtra. Languages, Germany has 5 languages. 95% of Germans speak one language. India has 780 officially documented languages, 10,000 plus dialects. This is the good part, right? Now see the bad part. The bad part is per capita income. Per capita for somebody of the students, it is the average income of an individual in a country, right? The average income of an individual in Germany is 38,74,000 approximately. 38,74,000. It is world rank number 17. India, the average income is 1,90,000. We are at 128th rank. How can we then now think of the literacy? Look at literacy rate. 99% above age 15. So 99% of Germans are literate above the age of 15. Why I chose the sentence above age of 15 because everyone tells me, नहीं बोलो पुराने काल में ऐसा था. नहीं पुराने काल में नहीं. Even today, India's literacy is only 74%, guys. That's a reality. We live in a city which is covered by maybe only intelligent people. But if you go 3 hours outside Pune city, you will come across literacy rate which is unbelievable. So this is, just look at these things and tell me really, is the problem statement which German census had and what we see today, is it same? If it is not the same, why are we adopting the solution which was given by the Germans for their companies? I mean, think of it. Look at the stark, it's not even close to it. It's not even like we are nearby to the German situation. We are way ahead and way far away from actual reality where we are today and where Europe is. This is our real problem. Our real problem is a huge population, and the population which is not even going to go lower in the next 2 decades. We are still going to keep increasing our population for the next 2 decades. We don't have a healthcare system like Europe. Our healthcare system is not there. It's individual health driven. Now, of course, there are some efforts being done by the government to bring at least some people under the healthcare. Crime and corruption, obviously linked to the per capita income. We have a significant, either we like it or not, a significant portion of our life goes in identifying crime and corruption. Our literacy I already spoke about, 74% only above age of 15. Languages we spoke about. So these are our problems which affect the industry. I forgot to mention one thing, sorry, is contract labor. I don't know if the students know, I'm sure the men in the front know. India employs, the dark reality of Indian manufacturing sector is we don't make employees permanent. Tatas, Mahindras, you take any name, they will not make employees permanent. They will fire every employee after 8 months. That's the truth. I understand the reason now because they want to avoid union formation and all of that. Fine. But the reality is every 8 months, you will send 80% of your staff out and bring in new 80%. Nobody wants to talk about this because, let's not talk about this because this is the Tatas and the Mahindras. But the reality is that, right? I started my career in Tata Motors, guys, so I can tell you it's true because I worked for 5 years in Tata Motors. So this is what happens in reality. Whether we like it, we accept it, this is the truth. Does Germany have that problem? Never. Germany, even up to manager level, you are joining under a union. I can tell you this because I worked for 8 years in Volkswagen also. So you join a German company in Germany, on the day one, you are under a union immediately. It's for you to opt out of union. This is where the differences are, and this is where our problem is. Just an example of the age which I mentioned. The left, the working age, and this is what was the census, which says there will be less people in the next 2 decades in Europe. There are more people now who are in the between 20 and 50, but later there are going to be less people. This is our pyramid. It clearly says that we are in a totally contrasting problem. That's again, this is a chart from World Economic Forum. Now what this says, is this is where we are right now, 2023, 24. Already we are around 8.5 billion people. In the next 2 decades, in let's say 2050, we'll be almost touching 10 billion people of population on the world. The orange indicates developing countries. The gray indicates developed countries. Clear so far? Now you will see 80% of the population is residing in developing countries which have problems which India has. 20% reside in developed countries for which Industry 4.0 is clearly the right solution. Autonomous robots, 3D printing, no problem. So the strategy which is there, and because we also cater to European clients, I'm not against Europe or European clients, automation is used technology to do more with less people. That is where automation should play a prevalent role. And like I said, we build machines. My first job is to build machines. Second job which we have is digitization, which is using technology to do more with more people. We cannot have less people. It's beyond our control to have less people now. So we have to digitize so we can do more with more. And that's the only way forward for India, is not do more with less, because I can't have a situation where I put 150 robots instead of putting 250 people and have those 250 people unemployed. What to do with them? How do we solve that problem? Because we may think it is not our problem, but trust me, when you think of what happens when you don't have money, hunger, food, crime, corruption, it will become your problem, whether we like it or not. We can't live in a castle which is protected forever, right? So we have to think really, can we do more with more? And that is what is possible through digitalization. So the Indian context, what I mentioned is why smart manufacturing, the topic is not really picked up. Because the reason is because everyone tried to implement Industry 4.0, which is an expensive system. And I have put some solutions of my own intentionally outside for display, a collaborative robot. Cost 21 lakh rupees, the one which is on display outside, and you add the safe skin feature, it's 4 lakhs, it's 25 lakh rupees for a collaborative robot. The minimum salary as per the government is 17,000 rupees. Now think of how many months you can pay to an employee with 25 lakh rupees. And what are we really achieving by putting a collaborative robot? If you can give him a digitalization solution which avoids his errors, which avoids mistakes, which ensures he works at the similar efficiency of a robot or a cobot, why do that kind of investments? And that's the we can do, we have that. But I would like to just think, why should we do? Why should I put 10 such 2.5 crores of collaborative robot? Because actually I get customers, those nice ones which I mentioned, to tell me, we want at least 15 robots in the line. When I ask them why, no problem, humans are a problem. Well, that's nice to know humans are a problem, because how do you fix that problem then? Wo robot dal do aap. Because big companies, sorry to say again, big companies can afford to put money, right? Nobody cares. Nobody cares. Release 250 people, put 10 robots, we are more efficient. But are we really more efficient? Did we not learn anything during COVID? Did we not learn in the 4 revolutions? Where does sustainability come? When we talk about climate change and all these big topics, are we doing justice? Because we are consuming more power now, right? India burns fuel, and that's a stark issue of EVs in India. You burn coal and you charge your EVs. Does it make sense? We burn so much, we are promoting EVs, but what do? We are burning coal and burning more coal now to charge our EVs. It's only solving the problem of the people who can afford the EVs. Because they feel nice now, oh, I am a clean fuel guy because I am driving an electric car. I am using electricity. But somebody in Chandrapur is burning more coal. I don't know if people know Chandrapur is a district that's where the real problem is. You go over there, guys, you can't see the sky. You can't see anything on top. That's the reality. And it has happened in the last 3-4 years, by the way. It's not like it's happened since beginning. And that's the Indian context anyways. So we should be able to do something which is our strength is our young population. Our young population, and again I'll tell you one of the statistics which came up in my Odin education discussion is India has 18 crore students or children in villages. Total out of 140 crores of population, we have got 25 crore children under age 18, sorry. 24 crores under age 18. Russia's population is less than that. Just think of it, that we have got more children under age 18 than the whole of Russia's population. Out of 24 crores, 18 crores are in villages. That's our strength. And this 5 trillion economy which we all talk about, it won't come into effect because the reality is after passing 12th standard, and then for all the students over here, it's a very important statistics to understand. If you think that a villager or a school, a guy in a village, after passing 12th standard, 49% of youth are unemployed. And you can go and check on, it's on government statistics. 49% of India's youth are unemployed after passing 12th. How many people can afford engineering nowadays? How many people can afford to be a graduate every time? So what do we do about making those 49% at least employable? Is adding more automation and more machines and more sensors the solution? Or making them more efficient is the solution, right? How do we make sure, and that's why I've put some nice demos, and I would request all of you guys to try and make an attempt there, is where we have put solutions where anyone with zero experience, zero skill, zero idea of what a battery pack assembly is, can still make a battery pack. Which means you can literally go on the road, pick a person who is illiterate, bring him on the line with our solutions and ask him to do something wrong. He can't do something wrong. That's how powerful the software solutions are, which we have. And that's solving the problem which India has. I'm not making the line more efficient. I'm not making the machines more efficient. Because already I make machines which are 95% efficient. For all the industry guys who are here, you can tell me one guy who is even 75% efficient in factories. Everyone is on contract. Half the time they'll go 10 minutes early for lunch, come half an hour after lunch. You can't do anything. That's the reality, right? Then again, this human-centric approach is again what is the government is also promoting. Right? If you see Independence Day, there was a right stark mention that we should be doing development which is human-centric and humane. That's from our Prime Minister. Just last week, he repeated the entire thing again when in the G20 summit, the first header is we must fulfill responsibilities with a human-centric approach. So if the government, which is funding C4I4, is saying we must do human-centric, and I feel, and like I showed you, Industry 4.0 is not human-centric, it is machine-centric. Should we not change this to C4I4 to something else? It's a government initiative, right? How is C4I4 then a relevant topic? It should be C4SM. Center for Smart Manufacturing, right? I think there's a class getting over now. Either you guys agree or you disagree. One of the things. Right, so no, I think I just wanted to take a pause and ask, that was my question in the beginning, that I don't know whether this place should be called C4I4 because it is relevant. I don't know. I'm not sure Industry 4.0 is relevant to us in its complete totality. Yes, there are some things which are relevant, which are required, but we are not addressing every problem which we have, right? G20, 15th August, everyone is saying human-centric, human-centric, but we still see solutions which are improving machine efficiency only. And you can see it's still not efficient. So what are we doing to solve his problem then? Because everyone feels that I can give an instruction, write, sign, गलती हुआ तो ऑपरेटर का गलती था, मेरा गलती नहीं था, मैंने साइन करके दिया था बराबर से, right? That is the reality of Indian manufacturing sector. What we are trying to change is this. There's an instruction in his local language which he can select, because you can have a guy who knows Hindi in first shift, Marathi in second shift. That's the reality of Indian manufacturing sector. We have that. We have people who come in the first shift who only know Hindi. Second shift, you might have a Gujarati guy coming there. So what do we do? Because Germany will never think of this problem. Gujarati, they don't know, right? That's what we do with our softwares. Fine, you are a Hindi speaking guy, select Hindi. When you go to ATM, isn't it so convenient? You get, right, English, Hindi, Marathi. Why not in our manufacturing world also? Why we leave that poor guy to read this and figure out what he has to do? That's a real life example. And then of course you get no code instruction. That's all the technicalities of how to get reports and everything around that. Another unique example. This is what is on display. You can see there are 4 cameras on our stall outside. Yes. Yeah. No, so instruction for the operator is a blue thing. This is not for the operator. This is for the operator. This is for the industrial engineer, for the process engineer, for those guys. For the operator who has to decide, because these instructions for the operator, right? So I have converted everything from here to an actually easy to understand language with a camera on top to guide him, and an instruction is in his language, which changes automatically. Everything is in, you can go over there, we have put there a cockpit assembly or how it is done, the tutorial of that, and you can see it's in all in Hindi. So this is the device which is on display outside. You will see the same stand outside, which is our what we call as a phantom device. Why phantom? Because you don't see it, but it stops you from doing something wrong. That's why it's called Odin Phantom. This is what it does. And again, an example is how phantom, you can go and see this. I can stop an operator from working if he doesn't wear safety gloves. Because every time we just put gloves pehno, right, of nice food. It was fine till a point. The problem in electric vehicle battery pack assembly is if I don't wear ESD gloves, I will burn the factory down. Because I will have rings, watches, they will short circuit the batteries and there will be a fire. Now how do I tell and leave the instruction to the operator to figure out, I have told you on a piece of paper, wear gloves. But how do I stop him? Because, or if he doesn't follow my instructions which is written on a piece of paper somewhere, Are we doing enough for the operator? Because we are risking not only his life, but the entire company is at stake now. And that's what we do over here is we detect using AI, is he wearing gloves or not wearing gloves? If he's not wearing gloves, system shuts down. You can't work on the station. Go and wear gloves first. So that's what are some examples of how we are able to ensure operator safety, plus picking the right parts, push buttons are replaced, angle of the tool is selected automatically. Yes. So if it can, you can see I have configured to detect number of spots. Right? Now if in these spots the gloves are torn, it will stop. Because I can't detect the whole glove. I have to make, it's called pixelating, right? I make pixels and I detect the pixels. Obviously, if I make many number of pixels, the processor will slow down. So you have to do a trade-off between how many pixels versus how many spots. No, it's not image processing. It is, we are definitely checking these spots. So one of my other favorite example is this example where end of the line, again how we as management passes the responsibility to our last guy. The last guy in any factory before dispatch gets a printout and is supposed to check the product and tick mark everywhere and make some comments and sign and say product is good for display. Oh, sorry, product is good for dispatch. Never have we thought, has he really checked something? This is again an eye wash for years and decades. Everyone follows this. And there is a signature by somebody here, yes, so and so guy for so and so industry did these checks, no issues, dispatch the part. We give him 45 seconds to 1 minute to check everything with no evidence whether he has done something or he has not done anything. Now and then again, it is again depending upon if he is feeling, how good he feels today. If he feels, yeah, signature, they will feel in the lunch break everything tick mark, and when the part comes, they sign it. That's also, you are absolutely correct. And variant wise is never there. If I'm making a variant A and a variant B or C or D, all have same checklist. They will never have variant specific checklist. So we try to change this again by bringing something called as Odin Ensure, where what we did was we gave them a simple industrial phone where we show them what they have to do. They have to actually take a picture. It's as per evidence, actually the time taken by making a tick mark and taking a photo is exactly the same. It doesn't make any difference. But now he only sees for that variant, that particular step. He also sees a picture of what he has to take photo of, because sometimes you don't understand. As a new operator, you may not understand where should I go and take or what picture, right? Was that English description? Guys, tell me honestly, if I look at this, use, where was it? There was some very interesting, use spectrophotocolorimeter test system to check. Do you think that guy who's standing on there knows what this is? He has no clue. What he has written? Okay with tolerance. Even I didn't know what is this spectrophotocolorimeter test system. But okay within tolerance. God knows what that means, right? But this here, he will get, again, language can be changed, photo, and take a photo, or is a very nice feature called as raise alert. Because I can raise an alert immediately and call my supervisor. So there is a problem here. I don't know what to do because I am not authorized to decide or dispatch. So I can just press a button here and say alert raised. Somebody please come here and tell me what should I do with this. At least the people who sign those nice SOPs will get the information. They'll come from their offices and come and see what is really happening on the line. And not just count in the end of the day how many OK reports came. So that was, yeah, I don't want to go into more and more details, but there are such nice solutions which we have. Like I said, the whole focus is even like a very nice solution of behavioral change. How do you carry out a behavioral change on an assembly line? Because operators make and decide the process. They decide the production output. Isn't their mindset and their behavior like you do oiling to a machine to ensure it runs smoothly? How do you oil the head of a person to make sure he works properly, right? And that's a software which actually we use psychological analysis to understand how is he feeling. Does he have any depression, anxiety issues? Is he always angry in the morning, happy in the evening? Those kind of things will help us in self-improvement. There are psychometric tests, plus there are gamifications. So everyone likes to online. He has to answer because he has screens. He can answer everything. We have also like for example, gamification is we did a nice project here for one of our customers where the operator wanted to work, but he did not know how good I'm working. Where do I see how good I am working? So we made a pie chart which shows him compared to where he's supposed to be, where he is. It's a simple pie chart. The green indicates where he should have been, number of parts produced. The yellow indicates is he leading or lagging. It's simple, number of parts produced. Now the fun part is now, sir. The fun part is if he delivers at the end of the shift 100%, automatically, without even anyone's information, the system generates a barcode which comes and pops up. Congratulations, you have achieved 100% efficiency. A barcode comes on the same screen. I showed you the same screen of the operator. Just go back to that screen of mine. Yes, this screen. End of the shift, if he has achieved all the parts produced, a barcode comes up. He has to take his phone, take a photo of the barcode, go to the canteen and take what he wants. What more can motivate him, right? Because he's a contractual guy, guys. Because he's a contractual guy. He doesn't care about performance appraisal. I'm not there for your appraisal cycle only, right? मैं अगले साल अप्रैल में है ही नहीं. अब क्या मुझे देने वाला 10%, 15%? मुझे आज क्या मिलने वाला है? I want to take home today a packet of biscuits for my kid. That is a more motivating thing for me than my performance appraisal, right? That packet of biscuit of 10 rupees barcode has changed that company's performance unbelievable. Because now everyone wants a packet of biscuits. They go to a dispensing machine, pay with the barcode, a packet of biscuits comes out and they go home that day. It's a simple solution, right? But then it solves a mindset problem. Right. Sorry, that's all I had to talk. Yes. They must change, right? No, I know, I agree. I agree. Well, then barcode can be probably changed to a serial number. I don't know. We can think of barcode to a serial number. Maybe they can write down a serial number that, okay, this is 1121001 is my unique serial number. I mean, there are ways. I mean, I have come across, sir, majority of the times only intent is required. Right? I honestly feel that if the companies have intent, they will come up with unique solutions. It's just that the amount of internet, the amount of social media we use in our daily lives, and I think Mr. Kilosar was absolutely spot on in the morning. We are so comfortable giving barcodes, scanning barcodes, and I don't understand when companies talk about security. AWS is unsafe. Your entire banking is on AWS right now. You are scanning a barcode at a thela over there and paying him money from your Google Pay, which exposes your entire banking to him, but you are worried about keeping production data on AWS. I don't understand that mindset. It's just a mindset thing, right? Anyways, thanks a lot, guys. Thank you very much. If there are any questions I can take, otherwise that's all I had to talk. Sorry. The company's name? The company's name is Jendamark. We are a company which is in Khed Shivapur. We are around 300 people in Jendamark, India itself. There are a lot of such solutions. I can keep going. That was my question. So I started question topic by saying that should we change C4I4 to C4SM? Is that my question, right? Yes, sir. Yes. I4 only, yes. No, I4. Yes, sir. Absolutely, sir. No, I can't propose to you. I only wanted to say, yes, sure, sir. No problem. Thank you, sir. Yeah, I think there are no secrets, but there are no secrets. There are no secrets. I think there's only a mindset. Exactly. See, the thing is, again, I'll take Sir's cue, because when you talk of a solution industry 4.0, it already seems like it's somebody else's problem. It's a high-end thing, right? I'm sure we have come across such. The reason why we have C4I4 is also because people did not embrace it. We wanted to promote it. And I have been part of C4I4 for the last 3.5 years. I know. I have come and given seminars here. We are educating people, and they go back thinking, I don't know how to start. right? And I always tell them, start with what you know. Please put a barcode at every station which you have. You know, simplest, I'll give you the simple example, guys. You can take a document today which you have in any industry, scan it. Please scan it. There are several free ways to convert that and send it on cloud. Generate a barcode, free apps which are available. Put that station document on a barcode and ask your employees to scan it and read. It's the simplest step to start digitization. Don't do anything more. Just take the document which you have. Maybe it's a safety instruction. Right? Maybe it's a TPM. Let's stop chopping trees every time when there's an audit. Every time in my company I've seen, every time there's an audit, fresh printouts nikalo. Right? Hundreds and thousands of people are printed because there's an audit. Why? If you have a barcode, yeah. Thrown away. I started my career in Tata Motors. नहीं बस सवाल का जवाब दे मेरा हो गया already. I started my journey in Tata Motors 5 years and then 8 years I was in Volkswagen. So I was 5 years Tata Motors, 8 years Volkswagen, and then I joined Jendamark. I am the CEO of Jendamark. Right, sir? Thank you very much, guys. Thanks a lot.
So our next fourth session for today will be by one of our tech partners, CLPA. So I would like to invite Rohan Vilas Gawali sir, Senior Manager at CLPA, for his session on the future of Open Industrial Ethernet.
So, good afternoon, all. I'm Rohan Gawli from CLPA India. Also, I am the member of Mitsubishi Electric Technical Support Department. So, today I will discuss on the protocols. So, there is a lot of protocol, and the protocol is mainly used for the data exchange between different like devices, factories. So I will discuss on the protocol, and which is CC-Link family protocol. So this is the typical industrial automation and control system. It has a 4-layer four layers. First is field layer, control layer, supervision and production control layer, and then the information layer. Normally, to exchange data between two layers, there is a one field bus, we can say bus. It is field bus between field layer to control layer. Then the factory bus between control layer to supervisory or the production control layer. And third one is the office network to exchange the data between different offices or the different locations of the factories. So I will discuss how CLPA or CC-Link family help to do this field bus, factory bus and office network, establish this type of connectivities. So typically in field bus or the field level, there are different types of the devices. As you heard, there is a safety IOs, then general IOs. It is different types of IO, then analog type of data. So we have to capture like temperature, humidity, pressure, such kind of data we need to capture from the field. Then there is some specialized devices like inverter, servos, robot, then energy measuring units are there. So they are the smart enough and they have lot of data inside and we have to take that data for further utilization. So next is the industrial connectivity. So in 1980, there is a discrete wiring type of the connectivity. So then next in 1990, it is field bus. So the data transfer from field to the master device, it is on the field bus. And in 2010, it is industrial Ethernet. And nowadays, it is on TSN or the 5G. So that kind of evaluation on the industrial connectivity. So approach to the network hierarchy. Normally in the field level, the data capacity is small, but the real-time capability. Then once we go to the controller layer or computer layer, the data size is large, but the real-time performance is less. So cater these types of all the things, we have different networks. Like for field level, we have CC-Link, then we have CC-Link IE field, then CC-Link IE control, and then CC-Link IE TSN. So nowadays, everybody goes toward the smart factory. So the smart factory, so it divided in different parts like office, warehouse, factory 1, factory 2, maybe the factory 1, factory A, factory B in different location or different cities. So all are connected to each other through this network. And this network depend on the protocol, on which protocol we are exchanging data between these factories. So the utilization, IT utilization is increasing, accelerate to the future manufacturing. So the main part is the data collection technology from the sensors. So there is nowadays there is a lot of smart sensors and they have a lot of data. And to capture that data, the data transmission technology required high-speed communication between devices. Then that data, captured data, then shared to data analysis, control level, and then data processing like cloud, edge computing in the computer layer. So this uses the IT nowadays in the manufacturing. Next is a future industry need to handle the big data, because lot of nowadays in conveyor or warehouse, there is hundreds of inverters connected to control the conveyors. So every data, that health monitoring of the inverter, capture and then analyze or the monitoring in the control layer. So it requires lot of information like machine to machine interface, IoT based remote monitoring, Then the analysis. Analysis is data collection and analysis of the equipment in the real time. So for the real time, we need a high-speed data communication. So CLPA, we have a protocol which will give the high-speed communication and big data capturing. Then the change in the focus, shift from the production phase to entire industry. So then the expectation from the industrial networks are the real-time performance. So need a fast network, then large data handling capacity of the network, then sufficient bandwidth of control data as well as the message data, then high reliable, then flexible to integrate seamless with upper layer and lower layer networks, effectively deal with the harsh environment, because there is a lot of collusion when we are using Ethernet. There is a data collusion or the factory noise are there, and need a simple diagnostic, or we can say a easy diagnostic of the network. So next is the network openness. So in industry, there is a two types of network. One is the open network and another is the private network. In the private network, the manufacturer has its understanding, or he has used its own protocol. So it is not open to everybody. So he will develop their products like PLC, IO card, and they are on network, and that is private network. But nowadays concept is of open network. So the protocol is shared among the different users or different manufacturers, and they build their devices like modular IO. So the modular IO, they are on different networks. So anybody can use anybody's modular IO. So that is the concept nowadays. It's called the open network. There is some advantages and disadvantages of open network. So in perspective of user and in perspective of the network manufacturer. So that's why I mentioned here there is a CLPA perspective. So user perspective, the advantage is the competition create better products at reasonable prices, because everybody knows that open protocol. So he can build the protocol in his device. Then multiple vendor environment where the users can select the best device. So everybody has a protocol. So the manufacturer or OEM can take that device from any manufacturer. So reduce TCO and support for the globalization. This is the advantages. And then the disadvantages, so ensuring interoperability is difficult. Then when problem occurs, investigating and isolate case are complicated. So in the perspective of the protocol manufacturer, like a CLPA, the expansion of market share, it is very important. Meet customer need by supplement our products with the partner product and increase the sales of the product. So anyone can use any device with its master PLC. So that is the use of this openness. Then the disadvantage is the entry of product from competitor companies. So that is the disadvantage with respect to the any protocol builder. So decrease the product price. So these types of some advantage and disadvantage of the open network. Next, now I will discuss what is the CC-Link family. So the CC-Link family, it is again the network, it is announced in the Japan first in 2000 as an open network CC-Link. Then in 2007, the CLPA announced 1 Gbps Ethernet-based network called CC-Link IA. And then in 2018, CLPA announced CC-Link IE TSN. So TSN is time-sensitive networking. So next, earlier in 1996 or before that, there is a private network of Mitsubishi Electric. for the PLC to PLC communication, like MailSecNet, then MailSecNet H, H, and the MailSecNet G. So this is the private network. So there is a very less product on this network. So then Mitsubishi decided to open this protocol for everyone. So in 2000 they built one association called CC-Link Partner Association, and they started they open the network and with the name of CC-Link. Then they come with in 10th anniversary CC-Link IE Control, CC-Link IE Field, and in 2020 CC-Link IE TSN. So what is the actually CC-Link means? CC-Link means control communication link. So we can this is mostly used in the industrial network for control and information exchange between the devices. So I will in my upcoming slide I will inform what is this type of communication and how we can use in industry. So what is the CC-Link IE? So CC-Link IE stand for Ethernet, standard Ethernet plus the CC-Link protocol. So we called as CC-Link IE, and it is a 1 Gbps network. And what is the CC-Link IE TSN? The CC-Link IE TSN is CC-Link protocol on industrial Ethernet with the time sensitive networking. So it has a capacity of integration of OT and IT. They with high speed, high capacity, and the high accuracy synchronization, as it is on time sensitive networking. So now I will discuss some of the network features. So in the CC-Link family, we have different of the network like CC-Link, CC-Link IE Field Basic, CC-Link IE Field, CC-Link IE Control, and CC-Link IE TSN. So what is the CC-Link? CC-Link is again the RS-485 based network. So we called as a serial network, and we can go up to the 2 kilometer distance with these networks is 2 kilometers, and the feature extensive range of partner products. So more than 1,000 models available on the CC-Link. It is again 485 base. Support device can be developed easily, and in version 2, high capacity cyclic transmission is possible. So on CC-Link, we can control different types of robots, inverters, servos with the master, and we can control or we can capture the diagnostic data in the master. Next is CC-Link IE Control. It is 1 Gbps network, ultra high speed, large capacity network type. Means we can share a lot of data between the different controllers. Then powerful network diagnostic feature available in this network. Mainly this network is used for in between controller to controller. So there is a different types of different shops in automotive. If you consider, there is a different paint shop and different shops. So we can connect each other and we exchange the data between these by using this protocol. The next is the CC-Link IE Field. So as I discussed the field devices, so this is we can say it is level 0 or level field level devices can connect in this network. So we can control servo system, robots, and we can capture the data from that. Next is this is designed 100 Mbps network, and this is mainly used for the machine level automation. So there is a lot of devices on 100 Mbps, and we, like servo, robot, and we connect or we can control the machine by using this CC-Link IE field. So next is the CC-Link IE TSN. So the some features of CC-Link IE TSN: accurate time stamping information and advanced analysis. Then network integration, Then utilize of wireless network and 5G. So nowadays the 5G communication is popular as it has a good bandwidth. So that we can use in the industry to connect the devices, different devices in the industry. So the capability of connection between the OT and IT. So this is the some features of CC-Link IE TSN. So this is some highlighted point of the TSN. So just I will discuss in detail what is the integration of OT and IoT. Currently, we are using different types of cables or infrastructure for the IO communication, TCP communication, and other communication. But by using the TSN, we can use single network type. So all the network coexist on the single network. So it is very easy to integrate the information technology and the operational technology. Next, traditionally, the motion controller, IO controller, it has its own networks. But by using the CC-Link, we can use the TSN and all are coexist on the same network. Then normally how the communication takes place, it is a token pass method or consumer producer kind of things. So that exchange data, so it takes lot of time. But with the TSN, so all are means sending and receiving on the same time with the time stamping. So it reduces the total cycle time. So big data and we can capture from the sensor level. So next is where we can use these networks. There is a lot of networks like TSN, control, field. So between PLC to PLC, we can use a TSN or control. Then for field level, we have TSN, field, basic kind of network. For servo, we have TSN, field, and SS init kind of network. And for secure communication, again TSN and field. So depending upon application and requirement, we can select the data. So whether we have to build network at field level, controller level, or the computer level. So there is one more video for the performance of the CC-Link IE TSN network.
Hi, I'm Tim Hyder from Mitsubishi Electric. I'm the product marketing manager for solutions and networking, and I'm here today with a brand new demonstration to show off our CC-Link IE TSN network. So CC-Link IE TSN is a protocol that runs on TSN technology or time-sensitive networking. This is a technology that we're very excited about, and hopefully in this demo, we'll be able to demonstrate that for you. So on the left side here, we have the master PLC. So the master PLC has multiple different networks. We have green for Ethernet IP, we have blue for standard Ethernet, and we have orange for CC-Link IE TSN. All of that network is passed up to a CC-Link IE TSN Ethernet switch. That switch is connected over to a remote station, which also has a PLC. So this is simulating two different systems, a master system and a remote system. It also has all the networks, so we have blue for Ethernet, the orange for IETSN, and the green for Ethernet IP. What the demo is going to do is the master station is going to spin a disc, this 6-inch vinyl disc. On this disc we have a white dot for mark sensor. This mark detection sensor will come up to a high-speed input module. The high-speed input module will then go to a high-speed output module and flash a bank of LEDs. Similar to vehicles, if you are familiar with tuning a timing belt in an automobile, it's a very similar concept. So basically the goal will be to spin this disc and flash and be able to see the TSN logo clearly. We're going to take the speed and the position of this disc and pass it through the network using CC-Link IE TSN over to the remote station, so both discs will be at the same speed and the same position every single time. What we're going to vary is the LED strobe. So on the left side will be TSN and that won't change, but on the right side we'll change to Ethernet and Ethernet IP and we'll see what that looks like. Let's begin. I'm going to turn the demonstration on and we're going to start out in CC-Link IE TSN mode. And as you can see, we can clearly see both TSN logos and they're identical. And that's the benefit of a deterministic network. So CC-Link IE TSN is deterministic. We have other cyclic based networks like Ethernet IP. So let me change to Ethernet IP. Now it's close, but it's about 20 degrees off, 25 degrees off. And that's off because it's a 4 millisecond network and there's a little bit of time delay. It's not deterministic, so we can't guarantee its location. We could also send the strobe signal with Ethernet, and now with Ethernet it's even more delayed, and that's just general Ethernet. When we send a packet out, we don't know when it's going to arrive. So again, that's the difference between just Ethernet or a cyclic Ethernet network or a deterministic network. So now that you've seen what determinism is,
So this is the deterministic network. So we can use in the industry. So now I will discuss what is the CC-Link Partner Association. So CC-Link Partner Association, this is the non-profitable organization, and we help to implement the protocol, CC-Link protocol. Then support for developing the CC-Link family product, confirm test for the partner products, promotion of CC-Link family and partner product through various exhibitions, seminar, websites, and catalogs, and standardize the activity. So this is the about the CLPA. So then the organization, so there is 11 partners, Mitsubishi, Cognex, Molex, 3M, Cisco, different, and we have different branch offices like China, Europe, America, Korea, and so on. And we have total 5 conformance test lab, 2 in Japan, China, Korea, and Germany. So this is regarding to CLPA association. So we work in 11 offices we have in world. So from headquarter at Japan, then Taiwan, China, and again India. So we have activity at 11 countries. So this is from my side. Thank you. Yes. Yes. Actually, now every devices, so which has a TSN built in, either software stack or the ASIC base. So it has the time stamping, time device inside the it, and it synchronizes the time with the master on every 1 millisecond. So it has the time synchronization, because it's synchronizing the time at every 1 millisecond with the master station. So if we are using switch, TSN switch, it has the ability of the clock synchronization. No. We have everything. Means we have field devices, we have switches. Not with only Mitsubishi, we have some Moxa or some manufacturer or Cisco. They are making the switches. So we have field devices, we have controllers, and we can transfer the data from controller to the computer layer with using the TSN. No, we have both. So we have a CC-Link for the field level, but we have devices with the CC-Link IE TSN for the field. So the servo, we have the CC-Link IE field servo. Inverter, we have a CC-Link IE field TSN inverters. IOs also on TSN. So we have a TSN network. But suppose you have a small machine, then you can use the CC-Link for the field level. But for the big machine, accurate type of the machine, you can go with the TSN type of the field devices. Okay, thank you.
Thank you, Rohan sir, for the deep, insightful dive into CCI Link. So we are finally at the last session of the day, which will bring us to the end of the series focused on monitoring and productivity in industrial IoT. It is my honor to invite Mr. Rahul Patel, Product Manager of Robotics at Omron Automation, India, one of our tech partners for today. The session will be on IIoT solutions for end user and machine manufacturers.
Thank you very much. Good afternoon, all. I am Rahul Patil. I take care of robotics for Omron Automation India, and I am going to take you through basically rethink manufacturing with the robotics and traceability. So there are certain challenges which are faced by the manufacturing industry. Let us look at that and let's understand how we can help to mitigate these challenges. So before going to touch upon with the industry challenges, let's go through the Omron business globally. So as a Omron as a company, we have got a 6.5 billion US dollar sales, and near about 29,000 plus employees globally we have with Omron, and we have got 5 divisions. So if you see here, so industrial automation business, which we call IAB. So this typically covers 57% of the business in Omron. And then there are other businesses like healthcare business, social systems, and electronics and mechanical component business. So these are also contributing to Omron Corporation sales. So major portion is covered by the Omron industrial automation business. So if you see global service and support network, so we have globally head offices in every continent like Europe, China, Africa, Asia Pacific, Oceania, and Japan. Japan is headquarter for Omron. So closely Omron operates over 120 countries globally and provides the solutions for automation to the industry through the products which is more than 2 lakhs of the products. So if you see the Omron India as a Omron Corporation, Omron Automation in India. So we established in India in 1996. There are 200 plus employee workforce which we have with us, and we have a warehouse at Bangalore, which is 18,000 plus square feet. We have one lab where we can do the proof of concept testing, which is in Pune for AOI. 2 repair centers, 3 training centers, and we do have 6 branch offices and 7 remote locations we operate in India. So one part which we have with us is Automation Technology Center, which is in Mumbai. So this is a state-of-art facility where we have latest Industry 4.0 enabled solutions we put there. And if anybody wants to see and anybody wants to have hands-on also on that site, so it is open for the customers. And the Pune we have the lab, but the bigger one is in Mumbai. Pune also we do. And we have 100 plus authorized channel partners as an extended hand for Omron to support the total business of India. So if you see the product lineup, as I said, Omron has got more than 2 lakhs of the products. So it starts from relay to robotics. So we cover all the portfolio which goes into the machine, into the process. So typically, if I talk from the input side, we have the input devices, which are sensors, cameras, vision sensors, code readers. So these kind of devices we have. Then if it comes to the logic, we do have the controller which can get connected with the cloud and the SQL database, and which can get communicated to the machine network on the Ethercat. And in that, the controller side, we have the vision controllers where we can connect 8 cameras, and we do have motion controls. So Delta Tau is a company which is taken over by Omron 5 years back. So this is now Omron Delta Tau company, and that motion solution which is coming under Delta Tau, now it is with Omron. And if we go to robotic side, so we do have very wide range of robotic portfolio, which starts from fixed robot, collaborative robot, and autonomous robots. And we do also cater into the safety services. We have our own safety consultants with Omron who can give the certification. And then the output side, we have servo drives and the VFDs. So yeah, let's look at the what's changing in the market. Nowadays, last 3-4 years, consumer demand has got changed. Consumers' expectations are, products should get customize or personalize. And to mitigate the consumer's trend, there are challenges which are faced by the manufacturers. So earlier the scenario was basically manufacturer used to produce one product in the mass production. But now this is not the scenario. There is a high mix of the product which is coming and low volume on that side is coming. And definitely to mitigate these challenges, manufacturer need to gain the flexibility in the existing production scenario. So there are ways to get the adaptive and scalable production line, so that can be given by the automation products. So let's look at the challenges what we have. Typically, if you see the challenges in the industry, so reliable and availability of skilled persons, and there is not much sufficient manpower to mitigate the demand from the consumers from the market. And there is again the dynamics, which is playing a major role, that there is very much uncertainty in the dynamics, which demands high mix and low volume kind of a production. And third one, which is very much major challenge, is the de-risking of the supply chains. And definitely to de-risk that, there needs a diversification. So it is with the vendors and it is the suppliers and the locations. So let's look at these two challenges, which are for the skilled person and the high mix low volume. How we can mitigate this kind of challenges. So definitely there is a way. So there is a way where we can address the challenges through robots. So robots are there to rescue and to mitigate the demand, which is changing, and scalable solution can be given through the robots. So yes, why do we robots? Why do we need robots typically? So definitely there is a need to improve the OEE for the line, then productivity, quality, and the employee. These are the areas where that improvement can be given through robots. So definitely the robots can take over the monotonous job, where there is a human which are working on the area which is repetitive and monotonous, that can be taken over by the robots, and the person that he can be put to the skilled job where he needs to be deployed, and he can use here his own skills. So it is not like that robots are taking the jobs from the humans. It is improving the efficiency, production, and it is reducing the pressure on the human's body. Second is the robots usually leads to give higher precision and accuracy and traceability kind of area, which helps to the production. And robots can execute the production process at higher throughput. And even, for example, you are changing the lines or you're changing the area, so it is a scalable solution. Only by changing the end effectors, you can deploy the same robot to the lines. So let's look the commonly used industrial robots in the industry. So there are 3 types of robots, and all types of robots Omron is having with Omron. So first is the area which is a fixed robot. When I say fixed robot, it needs a fencing, it needs a safety, and when it is deployed onto the production line, definitely all the safety parameters has to be taken care. So under that, there are the robots which are parallel robots, which is high-speed robots where you can go into primary and secondary lines. Then there are SCARA robots which can be used to secondary kind of applications. And there are articulated robots. So articulated robots are typically where we need a 6 degrees of freedom. So that area articulated robots can be used. Then second family we have with us is a cobot, which is collaborative robot. So it is human collaborative robot. It can work alongside with the humans to do the particular tasks in the applications. And third area is typically an autonomous mobile robot, which is typically used for the material transportation, line side replenishment. And this is human collaborative, so it can work alongside with human. It doesn't need any guidance or path to travel into the shop floor. So these 3 are the robots. Yes, one point is we don't have the robots which are heavy payload kind of robot. We have the robots up to 15 kg, which can mitigate the demand of the customer for high speed and repeatability and accuracy. So you can choose the best suited for the application. We can deploy according to that. So why we need robots? So as I said, typically to give the scalable production, robots can be deployed and the end effectors can be designed and deployed as per the requirement. So the versatility of these robots makes them adaptable by adding the end effector for to go the number of applications. So let's look one by one. Typically, there are some use cases also I put the applications in this. So parallel robot and SCARA robots. So typically we have payload capacity up to maximum 15 kg, maximum reach of 1300 mm. It can get connected on Ethernet and EtherCAT. It supports IEC 61131 PLC open programming, and multi-robot synchronization is possible with input and output tracking feature. So this is one application we deployed in one of the case. It is doing the multiple jobs, which is screw driving, picking and placing, and sealant dispensing. These three types of job done by single robots. So yes, there is another cases, some of the solutions which we given. So if you see this left side is a high-speed pick and place, typically used into primary and secondary high-speed lines, where the speed goes to 150 or 300 picks per minute, depends on the architecture. So this is a chocolate cookies pick and place. It is picking the chocolates from the input and placing onto the trays as per the requirement. The second is the SCARA robot, which is typically operates in the range of 40 to 50 cycles per minute, and the concept can be deployed as per the application requirement. And this is a spoon pick and place, plastic spoon that is picking and placing into the cartons. So these are about fix. Next is the cobots. So cobots, yes, we do have, we are starting from 5 kg to 20 kg maximum with a reach of 1300 mm. And it has got Ethernet IP and Profinet connectivity. And it has got 17 safety features, which conforms to IEC 10218, and it can be deployed to the system along with the humans as a human collaborator. Same screwing application with the help of cobot. So some of the solutions which we deployed with the cobots, while the here left hand side is palletizing application. So to pick the box and pallet as per the required format. And this one is a machine tending. The cobot can get also deployed into the machine tending solutions, where you can use it for putting the job into the machines and go for the particular task. And one advantage with Omron is we have got integrated camera. Although you can see here, this is an integrated camera. This has got a 3D kind of integration. So as per if you are having any object on the incline, 15 or 20 degree kind of incline, so it also performs the task based on the inclination, and it can be deployed onto the particular solutions. So that has that USP which we have with our cobots that can be used out. And even another area where we can see, you might have seen in the video, the cobots typically, if we are customers are not using for 24 hours, and he's using 8 hours one area, and second area he can transfer the same solution and he can deploy the same cobot by changing the recipe. So this kind of a solution also, and we can get the full efficiency of the product and deployed on 2 areas based on the requirement. Next one is autonomous mobile robot. So this is autonomous AMR. We say it is coming up to maximum 1500 kg, and maximum speed is up to 1.8 meters per second, and it has got 360-degree safety to check and to understand the obstacles. It has got audio and visual warnings, and it has got obstacle avoidance. And again, one feature USP which we have is we can deploy maximum 100 numbers of mobile robots in one shop floor. So one controller can manage the fleets, one controller can deploy the priority task based on the fleet management, and the task can be performed with the particular robot. And it has got opportunistic charging feature. Whenever it has got a time, so it goes and docks itself to charge on the battery side. So this is about autonomous mobile robot. And one area, so basically autonomous mobile robot doesn't need a magnetic tape or beacons. It has got a free natural navigation features, and you can redeploy the same robot for the environment by teaching the robot on the shop floor. So there are two ways: either you can give it the CAD file, or you can teach through the moving the robots on the shop floor. Some solutions which we given for this mobile robot. So this is a material management, line side transfer material. We can transfer, we can synchronize with the conveyor, and it can go and it can deliver the particular required material to the lines. This is one area which we can automate through mobile robots. And there is another solution which we say it is a solution, is a mobile manipulator solution. So if you see on the mobile robot, we can put cobot. So put together mobile operator and cobot, we can form a mobile manipulator, and it can be used for the particular pick and place task. And it can transfer the material by picking and go to the another location to deliver the material. So this is mobile manipulator solution. So yeah, so as we see challenges, so there is another challenge in the industry, is a de-risking of the supply chains. So how we are going to de-risk that? So let us look at that. So we have got another solution for this, is a track and trace. So definitely track and trace is going to help us to de-risk from the rejections and the recalls in the line. So in that we have got solution, we call it as MVRC solution. So mark, verify, read and communication. So this solution is used typically to get the data from the shop floor and give it to the cloud for the further analysis or traceability. So we have a laser marker. So basically we can take the laser marker and we can mark on the object. Object can be plastic or can be a glass. We can mark it out. Then there is a verifier. We have got a code verifier, where it can verify the code, 2D code, barcode that can get verified. And after verification, the reading can be done by the camera with the help of camera. And all these things can get communicated to the controller, which is our NJ controller, NX controller. And that data can be given into real time to the cloud server. So typically, if you see, this is not a PC-based architecture. This is a PLC-based architecture with a 31 character security given to the controller. And this also can communicate to the cloud on the MQTT and other protocols on the to the cloud. And it also can also get connected to Azure directly without having any mediator in between. Again, one good feature which I would like to tell, this is spooling function. So it has got spooling capability. If your communication is getting lost in between while sending the data, it spools the data inside the controller to 1 MB, and it transfers the data first in, first out to the cloud. Yeah, just look at the use case, actually success case, what we are talking here. So definitely there is an improved yield with the reliable marking with the laser marker. Then line manufacturing history and data can be taken to the camera, then code reader, and the same can be processed along with the image, like assembly results, inspection results, processing results. All can be processed to the database together. So there is a timestamp output together that we can get the timestamp details, and then that time what was the image captured by the camera, that is stored into the cloud. And later on also we can pull it up when any recalls or rejection happens. We can pull the data from the cloud in the future. So yeah, this is a challenge, basically supplier 1, supplier 2 and factory location. So all the suppliers data also can also get to the factory level, and from factory all the supplier data can be passed out or can be given to the cloud. So traceability in summary. So basically traceability, by traceability we can streamline the production line with the efficient routing, determine the exact cause of failure that can be detected, and track the parts to maintain the full accountability. So you can make accountable the supplier, who supplied the product, who supplied the part, and who was the operator, and what was the situation that time. So that all data can get tracked out from the database. So finally, yeah. So basically, we say automation. It is our, we say automation is integrated, interactive, and intelligent. So typically, if you see the network, we are on the information side, Ethernet IP network, where you can connect the cloud and you can connect the devices on Ethernet IP. And even, as I said, mobile robot fleet manager also can get connected to Ethernet IP. And there is a machine network. We typically say we use EtherCAT. So EtherCAT is a real-time network which can fetch the data from the machines and the controllers, and even from the robots. So any customer want to have the complete solution on one network, one communication. So we do have the solution where controllers, output devices, robots can get connected on the EtherCAT network. So that's it about automation. Thank you. So if you have any questions, so you can ask. It doesn't use any streaming software. It has got direct connectivity with the cloud. So there are ways to connect. We connect with SQL. We connect with DB2, Firebird, and even Azure also we do connect. So there is no streaming, and even there is encrypted data. Dark factory, yeah. So this is a concept which is coming in future, dark factory, humanless factory. It is in discussion. Yet there are some challenges and there are some regulations which are coming still, but it is in discussion. We have implemented a solution, humanless factory, but it has got not 1 or 2 human can go, but we can say that can be possible. Yeah, but it is in discussion. Because one case we have in Singapore for the assembly applications where all robots are moving, and the MoMA, what I shown, that MoMA is doing the particular task and that is giving the messages on that. So that is there. So we can say we can do that. Thank you. Thank you.
Thank you, Rahul sir, for the very insightful presentation. This brings us to the end of our series of seminars on industrial IoT. Thank you everyone for attending. Thank you for your presence. You can go and enjoy the exhibits if you haven't. Thank you. Have a good day.